look at how clear like most of the Gulf of Mexico is. It's supposed to go last weekend.
Okay, welcome to our weather discussion for the end of the first full week of classes for the year. How do you like that? Pretty nice weather here, wasn't it? Beautiful week. I don't know if we're going to have the same verdict a week from today. I think it's going to feel a little too warm here and there next week. But still, it's not going to be terribly hot, so that's good. But we've got a lot going on around the country, around the hemisphere. And so there's some interesting things to talk about. Probably primarily Hurricane Lee. Just now beginning to, you can clearly see a connection to the extratropics. We'll talk a little bit about this whole connection. And Patrick, I will go a little into the forecast on Biz 5D. We just have to see how some of these structures evolve. But we'll take a look at the current state of Lee. We'll look at the development of an outflow jet that's very dramatic and sudden over the last day and a half. That's clearly connected to the outflow from Hurricane Lee as it encounters the extratropics. And so that's a really interesting feature, and that has ramifications for the development of a really beautiful occluded cyclone off the southeast tip of Greenland. So all these things are connected. In 452, 751, yesterday we were talking about downstream development. And the only player in the atmosphere that creates new eddy kinetic energy is baroclinic conversion. So anytime you've got rising warm air and sinking cold air, you can generate new energy, throw it into the mix, and then it gets fluxed downstream. This hurricane has a role to play for this extratropical disturbance. And there's just no question about it. And quite a bit of the energy that's pumped into that disturbance is generated by Hurricane Lee. Not just advected around, generated by it. So that's a very interesting story, the details of which go well beyond what we'll talk about today. So that's one set of issues that we'll talk about. And then the other is this extratropical disturbance in Western Ontario that looks more menacing than I think the dynamics would suggest when we look at the upper level charts. Particularly this cloud band. I think we want to investigate not only its characteristics in the radar, I think you might even get a hint over Nebraska, parts of Colorado. It's kind of thinning out. And I'm not sure how much precipitation is actually associated with this thing. And there's not much of a thermal structure at any level that I can discern. But there is a really distinct and fairly impressive upper level trough at the lowest latitude of anyone we've seen this year so far. So this is fall coming by and saying, don't forget me. About a week from now, I'm going to be here for real, and maybe you won't feel me for a week or two after that, but it's coming. There's just no way to stop it. Okay, we can't quite see, because this is a false image, how dark it actually is at high latitude, but getting pretty close to nighttime at the pole, only a few days away from that. And then it won't come back until March 21st, by which time we'll all be exhausted by our spring semester. It's beginning this week, so that's just the way it is. Okay, so really nice picture of the hurricane. Pete's got a close-up I'll show you in a minute. I just want to point out, if you can barely see it, first of all, how shocked the western edge of the cloud mass is with these things. And this is thin, high cirrus. But I'm guaranteeing my dad's outside today right now looking at the little spokes in the cirrus and wondering what's going on with that. He's getting all excited, but at the same time disappointed that he's only going to get winds in the 30 knot range instead of 45 or 50. But I think that's probably going to be the case. Up in maritime Canada, different story. The storm is weakening. How can it not? These temperatures, you don't go swimming out here in the North Atlantic and enjoy it very much. And so it's not going to be able to stay as a tropical cyclone. But one of the core structural elements of a tropical cyclone, especially a well-developed one in a long history like Lee had, is the cigar-shaped PV column right in the middle of it. That takes a long time for that to go away, and you'll see that really vividly in Biz 5D. And then some of the ramifications of its structure on the broader environment. And then the ramifications of that on the jet. So there's a lot of cool things going on with that. Okay, so we'll talk about that. But let's first do our sort of regular survey of the country, and then we'll come back to Lee. So let's take a look, Pete, at, well, can you show us that close-up you had of the hurricane? That was kind of cool. Right over the northeast United States. Boy, I kind of wish I were home for this. Look at that. Isn't that beautiful? Look at these spokes in the clouds. Isn't that, and how regular they are. And also how obviously clockwise the rotation is at the tropopause level in the cirrus cloud belt. And how obviously counterclockwise it is down here. So this is a really well-developed warm core disturbance, and it's behaving precisely as you'd expect. But imagine being, look at the valley fog goes away, and then you've got hurricane clouds with regular intervals with these spokes. Absolutely gorgeous. And as I said, right here, you're just watching these things go by and wondering what's next. And they're emanating from the whole western periphery of the storm. So that's really a beautiful satellite image. And it's hard to see any eye left of Lee, but that's not uncharacteristic as they begin to weaken. So well, I won't say more about Lee now. We'll go to the Hurricane Center forecast or page a little bit later. So let's now take a look at, no need to do surface observations. There's too much to do, so we have to make some decisions here. Let's go to the super peats. And let us start, Pete, with, well, first, I want to see the radar first. We want to see what fraction of the clouds are precipitating around the country, and that'll give us something to hang our hat on. Oh, so this cloud mass is pretty decent precipitation feature, all the way from the Upper Peninsula down to about the Denver area. So that's a pretty good precipitating feature. Okay, so we'll try and say something about what's driving this from what we see at the upper level charts. We'll certainly want to do that. Here's the periphery. This is, remember, this is the 200-mile limits about here, and so you're barely seeing how intense the precipitation is with the leading edge of Lee. It's probably a lot more intense than that. But on the other hand, maybe some of this is precipitation aloft and it's not all reaching the ground. I don't know. But it's coming, gradually moving northwestward towards New England. The islands will be first, Cape Cod, and then the northeast part of the state of Massachusetts. And then here's some widespread convective precipitation down over the southeast. And not as widespread, but maybe a little bit more organized convective activity through the central part of Texas, and then some of it moving offshore. So broadly speaking, it's for the weekend. Okay, now let's go to the super peats. Let's start at 500 millibars. Imagine having maps named after you. That'd be pretty cool. So here's a 7 a.m. this morning. There's Lee. Here's Bermuda. It's Hamilton. And then Cape Hatteras. So it's in between Cape Hatteras and Hamilton, Bermuda. And you can see this kind of weak, positively tilted trough over the maritime Canada and north into far northern maritime Canada. That's the feature that's rather channeling the outflow from Lee. So it's out in this region, Gulf of Maine, Bay of Fundy, up into Newfoundland. And then here's the upper trough that's associated with the cyclone we saw spinning around in western Ontario. And it's a fairly impressive upper level trough, very sharp curvature maxima. It's got a downstream ridginess to it too, so the subgeostrophy at the base of the trough is not going to be the only, it's not going to be confined, the divergence won't be confined to the eastern portion of this. It'll be kind of widespread, and we saw that in the cloud mass. Minus 22 at 500 millibars doesn't sound really cold because it gets worse in the winter, but for right now, that's pretty cold. This is not even the end of summer yet, and we're at minus 22. And so, we had water spouts at Wind Point and Kenosha the other day when another one of these kind of minus 22-ish air masses passed over and had thunderstorms over the lake. So this is pretty chilly air and indicative of a pretty intense upper trough. Last week at this time, I think we had to go all the way up into the Labrador Sea to find anything resembling an extratropical type disturbance. This time, we're right at the border with Canada and the U.S. So features are gradually finding their way equatorward, as they will when the high latitudes cool off. And so this is the first of the bunch. But notice the thermal structure. It's cold in the middle, but the thermal structure is fairly weak. There's not a really strong horizontal temperature gradient at 500 millibars. There often isn't, so that's not entirely surprising. But sometimes, as we'll see later on, you get some really strong upper fronts. They're kind of interesting, but they're a little bit later in the season. Let's take a look at 700 millibars, hoping to find some evidence of a little more thermal structure. Now here, it gets you excited maybe for a second. Here's the dollop of coldest air at 700. Then you've got this little bit of a thermal ridge out ahead of the trough axis. But that's just a little dip of slightly chillier air again. So one doesn't see a very strong gradient in the temperature at 700 millibars. And then the winds are very weak across the entire eastern half of the United States. The dominant feature is Lee, and in between Lee and this trough is a giant kind of flat ridge at both 500 and 700 millibars. So no particular evidence of a strong temperature contrast. Even looking at the numbers themselves, 3 degrees at Green Bay, 2 at Minneapolis, minus 2 at International Falls. That's about as good as you can get. 4 degrees across the whole state of Minnesota is really nothing to write home about. What about 850? So at 850, the geopotential height minimum is kind of not so well organized across Ontario and parts of Manitoba. And again, not much temperature contrast It's 1 degree colder at International Falls than it is at Minneapolis. It's 14, 13, 13, 13. Everything's uniformly the same temperature here. So it's really hard for me to understand, based on this, what's really organizing that linear band of radar and the linear band of cloud. There's no particularly obvious dynamical mechanism that would be doing it. There is a sharp wind shift. This is about a 160 degree wind shift between North Platte and Omaha, and that's right in between, right sort of in the geopotential height trough down in this way. What I think we saw yesterday in 452, 751 was this trough began its life as a lee side pressure trough. And so it had sort of a warm axis exactly coincident with the geopotential height axis. What happens as these features move away from the high terrain that spawned them is that they start to lose that characteristic structure. So that thermal structure gets a little bit discombobulated. Somehow, for reasons I can't tell you right now, somehow this whole vortex structure without much thermal contrast is able to sustain a cloud and precipitation element to it that really does look like a healthy secondary circulation. So that's a little bit of a mystery to me, I will admit. But we haven't gone to the upper troposphere. Maybe some of the mystery will be relieved when we go there. So any comments or questions about this so far? Okay. Let's go to 300 millibars peak. Just to take a peek. And there's no big answers here. One might have expected or hoped that there's a jet streak that kind of runs right along that cloud band to its north and west, and that perhaps something associated with the jet streak could have given rise to an ascent in one spot there and an ascent here, and it makes it look almost continuous, even though maybe the ascent forcing is not continuous. All of that's blown away when I look at this map. I don't see any particular evidence of any of that. So it's a mystery to me why that's the case, and I'm glad I don't have the challenge of trying to figure it out on the fly as an operational forecaster, because it's a bit of a trick to do that. What I want to do next, though, is, well, I'll just draw your attention to this feature. 131 knot jet. Here's Lee at 300 millibars. It's a warm bubble. And this is in the outflow channel of Lee. Now, let's go to 200 millibars, Pete, and let's do the movie. And stop it before we get to the end if you can. We did. Let's go back. Okay, right here is good. So this is Tuesday. Very few places where the wind speed's over 90 knots. This is the only one I can see right here. At 200 millibars. So this is, really high, and so you expect you're going to see some subtropical jet in the lower latitudes, maybe even pieces of it that have made excursions to the north. Let's click ahead one at a time. We're going to go into Wednesday. Still 100 knots, that's pretty good. Remember, here's Lee. You can tell by the signature of the warm air at 300 millibars. This is Wednesday night. Not anything particularly interesting. Tomorrow, Thursday at 7 a.m. What happened here? Go back one. We have a 97 knot wind backs in this location with Lee way down here. Let's go to the next one ahead. Lee moves to the north and east, and suddenly 131 knot jet shows up. Let's keep going. What? Now we're into the 167 knot range. This is a rapid jetogenesis event that is a consequence of the outflow from Lee. Here's the warm bubble for Lee, and there it is. So what's happening is this is all tropical convective air, low PV, high theta E. It's being thrust upward into the upper troposphere, and tremendous tilting of the tropopause is occurring right in this location because it's running into a mid-latitude tropopause over Canada and the northern United States. This thing here is like a sprouting tent of low PV that's tilting the tropopause here. Anytime the tropopause has a significant tilt, you get an extreme, or you get a change in the wind speed. It gets more and more intense. And so this is what's beginning to happen here in the outflow of Lee. And let's go one more. This will be Friday morning right about now. 167 knots, the whole thing has progressed further to the north and east. Here's southeast Greenland. So this jet feature has an extension to the region where we'll see cyclogenesis over the weekend. So this whole thing emanating from Lee is responsible for a downstream development southeast of Greenland. And I'll show you some more evidence of that as we go further on. And at 200 millibars this morning, there's our upper trough. Don't be fooled or concerned that it's the warmest air over southern Lake Winnipeg. Of course it is, you're in the lower stratosphere. So that's warm air. And in fact, there's some ideas about that have been, that were in the 1990s when I was getting my degree. People were talking about warm advection in the lower stratosphere as a development mechanism. It's a good idea, except you got to forget that there's 50 millibars of air above you, and there's some problems with that. But it's not a bad conceptual idea. So deep troughs in the lower troposphere are warm bubbles in the lower stratosphere. Okay, so I love this jet feature. Now I want to go to Viz 5D and show you a few things on that. And mostly about Lee. So Pete will be driving, and I've tried to set some things up, but undoubtedly, Pete, I haven't set them up well. This is the GFS 104 grid over the North Atlantic, first of all. We're going to just tell you where we are. And this is sea level pressure every 4 millibars. So there's Lee. This is this morning or last night, sorry, at 7 p.m. I didn't want to take a risk of getting a model that hadn't completely come in, so I took 0Z. So here's Lee. There's Hatteras. Hamilton's over here, Bermuda, so you're actually closer to here. And the storm's on its way in there. And there's, I forget what this one's name is. What is it? Margot, yeah. Okay, this has been a really active week in the tropical Atlantic. I mean, these are strong storms. Both of them have had a history of being really strong, and luckily no one has been in their path, except maybe some unfortunate sailors, which I hope has not been the case. I haven't heard of that. Let's click ahead a couple of times. Oh, no, don't click ahead yet first, Pete. Let's do, let's look at the tropopause. So here's the 2 PVU surface colored by pressure. Where it's blue, the pressure at 2 potential vorticity units is quite low. Where it's red, the pressure is quite high, relatively speaking. We tilt it up a little bit and we can take a look at what this looks like in 3D. And so there you can see it's corrugated. And here are the interesting features that are associated with both of the hurricanes. So there's Lee, and there is, I already forgot her name. Margot. Yeah. There's Lee, okay? So this is a very characteristic potential vorticity structure for a tropical cyclone. In the core of the storm, you can see it. Tilt it down just a little bit, Pete. You can see there's the center of lowest pressure for both of the storms. That's where the PV tower exists. And the coloring just means this is the same value of PV, but the pressures keep getting higher as you go down to the ground. So tropopause is very high in the vicinity of both, and then you've got a core of potential vorticity substance, which is the product of circulation and stability. So it's really poorly stratified, so it's really strong circulation. And that, of course, is manifest in the strong winds of the hurricane. If we can, let's tilt up ever so slightly so that you can see how high the tropopause gets in the vicinity of these 2 storms. And yet, it's never very far from places where it's fairly low. And so places like here, where there's a steep slope in the tropopause, are primary places for very intense wind speeds. And to the extent that the tropopause slope can be massaged quickly in time, then you're going to have a fairly rapid change in the wind speed. Let's put the 50 meter per second wind speed on top of that in the surface. And here you can see it. We tilted around so you can see it. Right there, it adheres to the places where the tropopause has the greatest slope. And this was just about the time that we saw that jet generating as Lee kind of made its way towards the mid-latitudes and really made the most significant progress that it had made yet to the mid-latitudes, hitting the mid-latitude tropopause, pushing it up, and creating this jet stream. So this is the jet that we were interested in when I was showing you the movie at Truman Robot. Okay, so that's all pretty interesting. Let's go to the top view again, Pete. Okay, I did that. And let's take the PV and the wind speed off. Okay, and then let's go ahead a few clicks, even though this is now going into the forecast. Actually, it's not yet. Now it will be. Let's keep going. This is from this morning. This is about now. And we'll go a couple more times, just so we get the thing nestled right off Cape Cod. Right there, perfect. So this is midnight tonight. Let's redraw that PV cross-section. So, right here, sorry. And we'll just have to drag it so it's in the center of the storm. Maybe just drag this piece way over here. Perfect. Okay, let's see what that looks like. This is the vertical cross-section of PV. Well, son of a gun. This is 1, 2, 3 PV. So that's a 2 PVU surface right there. And it's looking the same. And this is now midnight tonight, so all the way through today. So this thing, even as it continues to make progress over colder shelf waters, it does not easily shed this vortex structure, this potential vorticity structure. And so that's pretty intense. And let's go back to the top view. And look what starts to happen here. Let's go back a couple of clicks. We haven't been paying attention to this. Keep going, a couple more. All right, so this is 1,006, 1,008, 1,004, 1,000 millibars. It's a kind of a weak little disturbance at the mouth of the Labrador Sea. If we click forward a couple more times, it suddenly gets really intense. This is 1,004, 1,996, that's now 992, one more, 998, or 988. So that's a fairly intense storm. If we put the PV surface back on top, look at this relationship. This is kind of interesting. Let's tilt this up. Center of the cyclone, if it's tropical, is precisely co-located with the high PV, precisely co-located. But if it's an extratropical cyclone, let's, and keep going, Pete, I think you got the right idea. Yeah, perfect, and then tilt it down. If it's an extratropical cyclone, the PV feature is, first of all, hanging off the tropopause, it doesn't have an extension to the ground, and it's to the west of the disturbance. That's the signature of the upper trough that's spawning that cyclone. Okay? And let's tilt back up again, just to get a sense of what's the space. I'll get rid of this cross section, I think that gets in the way. And just to see what's in this space between the PV tower from Lee and this high latitude feature that's coming in and being a little more tilted up to get rid of the sea level pressure for now. The lowest pressures or highest tropopauses in the whole map are right in here. And look at where they are if we go to the top view again. Look at the latitude they're at. If we can bring the map to the top, I think you can do that quickly. Look at what latitude they're at. They're at the latitude of northern part of maritime Canada. So this is really low tropopause height, pumped up by Lee, running into what was already existing at the high latitudes, the lower tropopause heights over the mid-latitudes. And the combination gives you a really strong PV gradient, which is one of the ingredients for rapid development. If we put sea level pressure on top of this, we'll see this relationship really nice. So you can bring that to the top. There's the cyclone in mid-latitudes. That's the spawning upper disturbance. Here's the tropical cyclone, and it's right on top of the PV. They're coincident. So they're very different kinds of animals. Here's another extratropical storm off the Iberian Peninsula. This is a long umbilical cord of PV from the high latitudes that comes down here and probably continues the flooding in Spain and Portugal that they haven't been able to get out from under. That's an upper level wave that's tied to that development. So really pretty cool stuff with this hurricane. So I think one of the science questions that could be interesting to pursue would be, to what extent does the outflow from Lee contribute to the production of the jet that we saw along the Atlantic coast of both the United States and Canada and into toward Greenland? And then, to that extent, how much does that influence the development of this fairly intense cyclone? It gets more intense in time. We won't waste any time on that. So there's a whole bunch of downstream developmental consequences. As this thing gets more intense, it pumps up the ridge downstream of it, and then that maybe leaves this thing orphaned and spinning off the Iberian Peninsula for rain in Lisboa for a whole week. It could be miserable there. If it's possible to be miserable in Lisbon, I don't think it is. And especially right here. Right off the coast of Nazaré, they have the biggest waves in the world right there, because there's a trench in the Atlantic right here. And so they have 100-foot waves there, which is a must-see. 100 feet. There's videos, you can look them up. But you can't really tell what a 100-foot wave is unless you're sitting there. I don't think the videos do it. So. I guess that's all I have for the discussion of some of these connections between Lee and what's going on in extratropics. So that's it for me. Pete, thank you for expert driving. There'll be more Vis 5B as we get more and more exciting and more mid-latitude type structures that I like more. But they'll come. It'll be fun. Thank you, Pete.
Mm-hmm. Thank you. I'm going to start with my bottom link here. So I'm going to start the same way I did last week. We'll look at the precipitation. Cumulative precipitation for the water year. So it starts in October, ends late September. Here's our little rain event we had over the week, but largely we are flatlining towards the end of the water year. So if this trend were to continue, we can look at QPF for the Madison area. We would be about 8 inches below normal. This map shows the average cumulative precipitation for Madison. It goes up, this is 37 inches. So 8 inches out of 37 is about 1/5. That's our deficit of our rain that we're projected to get. And as a consequence, if we go to my next link, please. We are still in a drought, and we'll continue to be in a drought. If we could zoom in here. And And we'll click Wisconsin one more time. No worries.
Oh dear.
I won't go through this. This looks almost like the exact same map I showed last week. Whatever amount of precipitation we got, that meager amount, has kept us in only a severe drought, which is surprising to me because we haven't had much precipitation over a couple weeks now, but we're persisting in this severe drought. Areas to our north and west are in this extreme and exceptional, but as I said last week, I expect this to creep and continue to creep over our area here over the next coming weeks. And then the conditions and outlooks, which I showed last week, but we don't need to go through, is the exact same, where we're expected to be in a drought for a couple months. So we'll continue to look at this and see if we get any large precipitation events that might break this drought, but it looks not likely, at least in the short term. Okay, so let's go to my next link, which is weather.gov. And we can highlight watches, warnings, and advisories. Largely nothing over the entire continental United States. This was a feature we saw yesterday. There are frost advisories in northern Pennsylvania. This is tied to that high pressure system, which brought us down to 42 degrees Thursday morning. Places in northern Minnesota, northern Wisconsin, northern Michigan got down to 30. I wouldn't be surprised if there was some 20s in places that aren't measured by weather stations, but that high pressure is drifting towards the east, and along with it, the cold air. A prominent feature, though, you can notice, these are all tropical advisories. So the darker shading are tropical storm warnings, and these are hurricane warnings right next to each other. If we, let's see, let's click on Maine first. We'll see everything. So there's a couple advisories out for Maine: tropical storm warnings, coastal flooding warnings, high surf advisories. There's also storm surge warnings down towards Massachusetts. There's wind advisories, flooding, coastal flooding advisories. Let's go back to the large map, if we could. It might be, this was my first take on this, you might say, okay, the influence of Lee is only in the Northeast. You'd be wrong. Let's click on Jacksonville, Florida. And scroll down, get a look. These are high surf advisories from Hurricane Lee in Florida. Hurricane Lee is over the off the northeastern coast of the United States. Let's go back a click, please. Let's click down near Miami. And we'll scroll down again. Rip current statements. This is from Hurricane Lee as well. So the influence of Hurricane Lee is stretching all the way down to West Palm Beach, Florida, which is pretty amazing to think about. It's not just tied to the Northeast. It is extending all the way down the entire eastern United States.
Yeah, there's probably a way that I'm unaware of to do like isochrones of what wave activity is responsible for these warnings, and it might have been generated when Lee was in the Caribbean,
Absolutely.
Days
Yeah.
ago. But it's
Yeah.
amazing how long lasting it is.
Yes.
The Atlantic is a big bathtub. If you kick it around, it's going to last a while before it stops being kicked around.
Right, you have 30 to 50-foot waves. They're just going to keep propagating.
Yeah.
There's nothing in between Bermuda and the United States. That all those waves are just going to keep impacting the eastern United States. And let's pull up the picture I had, please. And so I was curious, and I showed this in 452 yesterday. This is a look at the days since the last hurricane watch by National Weather Service Office. So I saw a tweet that said there has never been hurricane warnings issued along the far northeastern United States into Maine and Vermont, New Hampshire, and Massachusetts, which is interesting because it can be shown that hurricanes have struck this part of the United States. This map also shows some of these places have never issued hurricane watches where there are hurricane watches out right now, and there were. What I've come to decide is this is National Weather Service Office. So in 1970 is when the National Weather Service was founded. So any hurricane or tropical system before that was not technically issued by a National Weather Service office. That's my explanation as to why we don't have any hurricane watches, warnings, tropical storm warnings that we can show have never been issued by National Weather Service offices in this part of the world. And if we go back, you can calculate this. This dates back to 2008 was the last hurricane watch ever issued by, I believe this is Bangor, Maine. And we have hurricane watches out for Lee. So this has been broken. Since 2008, there has never been a hurricane watch issued from that National Weather Service office, which is kind of surprising. So that's an interesting factoid that I deep dived into last night as to why we never had any tropical system or tropical storm, hurricane, anything issued from the Northeast. Okay, now could we go to my next link, please? And we'll look at now forecast. Perfect. Actually, could we go back to the National Weather Service? I want to show QPF first. We go back, click, and down to outlooks. Right there. And I'll give away the punchline first. We go to QPF and the day 1 through 7. So this is a look at the quantitative precipitation forecast, all liquid precipitation forecast within a week. Here's Hurricane Lee making its impact felt on the Northeast and into maritime Canada. You'll notice there's a gigantic patch of little to no precipitation, including our region, which has been a signature that has lasted for a while. And then the Central Plains continue to see rain. This looks like almost exactly what I showed last week, where there was these systems that move over the ridge over the west, bringing precipitation. We are in a precipitation void, and then a tropical system moving over the Northeast. They don't need rain. They have gotten plenty of rain. Same with Florida here. And look where the bullseyes line up. Exactly where we don't want rain. Where we do need rain, nothing, pretty much. A meager 100th to 1/10 of liquid precipitation for an entire week for us. And then let's step through, we can step through day 1 through 7, just to show the progression here. So here's Hurricane Lee, heavy precipitation stretching almost into Maine and maritime Canada, the highest precipitation still off the coast. Here's that rain band we saw in the radar, which has just been slowly progressing eastward. It looks like it won't affect us today, but if we go to day 2, sometime in between day 2 and day 1 is where the precipitation from that feature moves over our region. And we'll look at when that might be. We can notice here's Lee, it's dying out, so it's speeding up, so you don't see as high precipitation totals. General raininess over the southeast and into Texas. We'll go to day 3. Gigantic void of any precipitation. Precipitation off the coast and into the northeast. We'll go to day 4. Same sort of story into most of the western 2/3 of the United States. And we'll go to day 7 now. And maybe we get into some precipitation, but this is pretty far out at this point. So we'll talk about this in the next weather watch. But largely, up until next Friday, we see little to no rain in our region. Okay, now we'll go back to this polar weather site. And if we could close or click the base layer, put on overlays, and do upper level, geopotential height, and 500, please. And what I'm showing here, so this is forecast from the GFS. We have the pressure centers labeled. I have isobars in the non-thick contours. The thick contours are 500 hectopascal heights. We see precipitation in the color shading, and then the lines of thickness are in dashed red, and they get to blue when they're below freezing. And we'll step forward to make sure we're at the right. Just scroll up just a little bit so I can see the time, please. Okay, we'll step 2 clicks forward. So this is about right now. Hurricane Lee sitting off the coast. Here's that precipitation band. Pretty well initialized for a couple hours after this model was initialized at 6Z in the sense. let's step forward 4 clicks. So this will get us to 6Z, which is around midnight locally. We can see Hurricane Lee is making its approach to Maine and into maritime Canada. We see that low pressure system and the associated rain band dies out as you lose diurnal heating. And then pretty much nothing over most of the United States except for Hurricane Lee around midnight. If we step forward 4 more clicks, this will get us in tomorrow about the same time. Hurricane Lee begins to move, and what's interesting is it looks like it's almost making impacts on Maine, making landfall on Maine. And I want to highlight this because if we go backwards 8 clicks to where the first time I showed, you'll see, let's go 2 more, show this. So here's the trough feature that originally was supposed to steer Lee into Nova Scotia and largely make it miss the United States. We just go 2 or 3 clicks ahead, look at the trough feature move away. So then you lose your steering for Hurricane Lee. A couple more clicks forward. Now Hurricane Lee is kind of up to its own device, which is something that National Hurricane Center is still predicting it to hit Canada. But if we just keep clicking, keep going until it makes landfall. 1 more. This is making landfall in Maine. And this trend has persisted. If we click, we can go different model time initialization. So let's go to 18Z Thursday. There's Hurricane Lee making landfall in Maine. Let's do the same thing. We won't go too far back. Let's go to 0Z Thursday. There's Hurricane Lee. It's a little delayed. Go 1 or 2 clicks forward, please, Pete. Making landfall in Maine. If we just pulled up very quickly the hurricane, I think we actually have it, National Hurricane Center, and click on Lee, and we'll pull up the official forecast track. That's a significant deviation from what they are saying. So I'm not saying that the model should be taken as the only thing to forecast Lee, but there is a slight deviation from where they think the center is to where the GFS has continued to sit.
The obvious question is, what's the alternative? You know, what makes the Hurricane Center do this in the face of 3 or 4 straight GFS forecasts that say something else?
No idea. I haven't read through what their explanation is, but
Maybe they have an eye on a different solution from another model or something, but I didn't see that either. I was looking at that this morning. I didn't see any evidence that that was the case.
they do say it has been wobbling around, generally moving north-northeast. Atlantic Canada is supposed to accelerate northeast on the east side of an approaching trough, so maybe they think that the trough will still stay there. But it does say that there has been no significant changes made to the forecast track, so potentially...
So, that's why. So in days gone by, they had it moving slightly further east, and so they don't
Yes.
want to rejigger that, I guess, right?
That sounds right.
Gets them in trouble.
However, if we go back to
Bad
the...
policy.
Go back here.
Why have these tools if you're not going to trust them?
Right. If you're living in far southeastern Maine, that would be, this is a significant shift. You might be in the center of Hurricane Lee when you were expected to just get the outer bands of the storm system at this point. So this will be something interesting to watch, where Lee actually makes landfall.
Yeah, very interesting. And speaking of interesting, look at this beast in the Gulf of Alaska. 979. There's a whole series of them. It's like an airport. They're all coming one in right after the other. It's like O'Hare on a Friday night. And they're all intense. Look at the baroclinicity on that thing, the leading one. Boy, it's incredible.
I'll do you one better. Let's go back, please, to the current initialization here. I think, yeah, that's perfect.
9-7.
We could scroll up, so our map is at the very top. Let's go back a couple clicks. I'll keep going. I'll tell you when to stop. So one more. Keep going. One more. One more. Oh, that's all the way back. Okay, perfect. So you may be drawn to what's happening in the Gulf of Alaska. I want to direct your attention to Greenland here. So we talked about this development of the storm system. Because of the outflow of Hurricane Lee, this trough, I'm going to analyze this just looking at the high contours here. So first, here's our center of our storm system. This is the center of our storm system. We have a trough sitting to the west and some semblance of a ridge sitting to the east. So based on the divergence of the anti-stroke of wind, we are situated right where the ascent should be maximized, which is directly where we see our low pressure system. Let's go 2 clicks forward, please. Now we see, here's our center of circulation. It is not exactly in between where we have our trough and where we have our downstream ridge, but there is a small center of low pressure that develops on the eastern side of Greenland. If you keep clicking, let's go 2 clicks. This becomes the main player. We are at 992. We are now, here's our trough. Here's our ridge becoming more distinct, directly in the center of it. Let's go 2 more clicks. 992, 985, 2 more clicks. 980, 2 more clicks. 975, 2 more clicks. 968, keep going, 2 more clicks. 965, 964. So we achieve the same low pressure as Hurricane Lee in this system that is sitting on eastern Greenland.
And it's of larger scale.
It's much larger.
Extratropics
Yes.
win again.
Yes. And if you were living, I don't know who lives in Greenland, but you were experiencing, this is some pretty crazy weather that you would experience. I mean, there's sort of a pseudo high because Greenland is an ice sheet, but you can imagine 964, if you're just at sea level pressure, this is about 50 millibars, maybe 60 millibars difference. You would have incredibly strong winds, high waves, and it's snowing outside, which would be pretty cool to experience. Then the last thing I want to touch on, we could just go, oh, this will be perfect. I think if we just stay on that website, it would be perfect. So this is now Saturday evening. Let's go back actually, one or 2 clicks. Okay, so this is now looking at Saturday evening around 6 p.m. local time. And if we go back one more actually. So the model wants to develop some sort of low pressure just to our southwest and along, not even a baroclinic zone, along some sort of boundary that we had been seeing that persisted in the radar, and then that has just been slowly sliding to our east. Here's a line of precipitation. Let's go forward 1 more click. This is really the only time that we are expected to get precipitation, Saturday evening. If we go 1 more, dies away. And that's the signal of precipitation that we were supposed to get from the QPF. It's unclear to say if this will actually develop. You can look at other models, but this is a small window where we could get any precipitation before, look what's to our west. Here's a gigantic ridge on the lee side of the mountains. You can see a thermal ridge extending all the way up almost into Alaska here. And if we just click forward, you can just keep going, Pete. We can see this ridge generally move towards the east. And if we get into Tuesday here, so now this is Monday evening. Now we see the influence of this ridge and we start to heat up. We start to get southerly flow. If we keep going, now we see pretty strong warm air advection over our region, and we sit under this ridge for an extended period of time, a couple days. Looks like Tuesday through Thursday into next week. So expect warmer conditions than what we have been seeing into next week. Okay.
Me?
Yeah.
Oh, I was just going to mention before the discussion where you were talking about the that precipitation band with the low pressure. NAM also has that pretty well developed.
Okay. So it'll be something to look at for sure because it's very short lived.
That's probably why SBC put a marginal out for Iowa and Illinois.
Okay.
Yeah.
So maybe it's general thunderstorms, if anything. Jake, yeah.
Yeah, so that extreme cyclone off of Greenland that's developing, did you say that was associated with the jet streak that was being developed from Lee?
Absolutely.
Okay.
It's a contributing factor. I
Yeah.
mean, to say that it's only that is too much, but
Gotcha.
it certainly contributes, it seems.
Right. Professor Martin took that approach. I just took the approach of I'm just going to look at 500 millibar heights and do the same sort of diagnosis of where we should see ascent in that cyclogenesis. And there's definitely more than what I'm talking about. There's a feature that sometimes sits off the east coast of Greenland that's called, I don't know what it's called, but it's a positive PV anomaly due to Greenland being a gigantic ice sheet. So that might have some influence. I didn't look into if it did or not, but there are some features that are contributing to a fairly intense cyclone that will develop from 992 to 963 in 24 hours. Any other questions or comments? Yeah?
I just noticed on some of the long-range forecasts for U.S. precip that there are some days when almost the entire United States has no significant rain. Maybe 3% of it has significant rain, 97% is dry.
Absolutely. I mean, could we go back to the very first, or one of the earlier times in this, like around here, please? I would take a guess, that's a contributor of this ridge that extends well up into Canada, well north of Hudson Bay. We saw this in the analysis as well. And so with a ridge like this, you're just gonna have systems moving up along it, and they largely miss the United States, would be my first cut guess as to why. But you're right, there's not much in the ways of precipitation from the United States over the next coming week, aside from Lee. All right, that's all I had to present.
Thank you, Patrick. Thank you, Pete.